Here's another nice little practical application question. You've got a parabolic archway. Now think about it. What's the point here? Well, if you think about it, this is a bridge. This is going over, let's say, I don't know, maybe another road that's going underneath here, and there's your traffic beaming down this road like this. You might have to do some engineering on this question, figure out the archway, then you can kind of put this into something called a CAD program, which is a computer-assisted drafting program, and you could figure out how much concrete was needed, what's the time that it's going to take to build this archway, and all kinds of different things. I think it's kind of a neat question, and it doesn't have to be necessarily with roads. This could be an archway, let's say, in a public building, and you're now an engineer having to design the public building, and they want a certain archway like this. Why not? All of this is really, really practical application questions. So the most important thing to realize here is that you've got a parabolic arch right there, which is 280 centimeters to 216 centimeters. And look, you can figure out that vertex real quick, because from here to here, halfway there, because it is symmetrical, is 140 centimeters. So our vertex is 140, 216. There's our vertex. Now we're dealing with some bigger numbers. Also, what else can we do? Where can we put the XY axis? Well, you can put it wherever you want. Some people will say put the XY axis through the vertex, and you can do it that way. Sure, if we do that way, this number is no longer valid. Think about it. We started here and went this way and up. So that's not a good place to put the axis at all. I would put the axis right here. There's your X, there's your Y axis. Now this point is valid. You went out 140 out this way, you're going up 216 out that way. I like making one of the coordinates 0, 0. That becomes super easy to deal with, especially when we're trying to figure out the formula. See how it works? Okay. Question, what would this formula be? Well, of course, if this thing has a width of 280, that other point would be 280, comma, 0. Look at that. So you could use either this point or this point. I'm going to use the vertex. 0, 0 makes this incredibly easy to do. Okay, so here we go. Write an equation of the quadratic, okay, in vertex form for the archway. Simple, simple. Here we go. Y equals to A. X minus P squared plus Q. Let's start putting the values in. There's my X, there's my Y, there's my P, there's my Q. All right, so my Y equals to 0. My A we don't know. My X equals to 0 minus a P value of 140. We're going to square this. So of course we're going to use a calculator right away, plus our Q value, which of course is right up here at 216. Okay, so obviously our A value, because it's shaped in this shape, is going to be negative, but we have to figure out what that is. All right, here we go. 0 equals to A. Now you got 140 minus 140 squared plus 216. Okay, let's bring up the calculator and let's figure out what that value is. Okay, so let me drag this over here, clear this out of here, boom. Okay, so minus 140, so bracket minus 140, bracket, don't forget, if you have a negative and you're squaring it, it has to be in brackets, squared, okay, plus 216. Oh, sorry, made that wrong. Wait, let's just do this again. Back that up. Oops, 140 bracket squared. There it is. Okay, just hit enter. All right, that's 19,600 A's. And that's why I had to change this, because I forgot about the A value. I'm not just adding it. I have that A value to worry about. So 19,600 A's plus 216, that all equals to 0. Now, I can subtract the 216 from both sides. Okay, and it's not going to be an addition, it's going to be a division right away. And that's where I made my calculator mistake earlier. Oh, well, I'm only human. Okay, that works out to be negative 216. Divide this by 19,600. 19,600. Let's go back to our calculator right here and go, okay, so minus 216 divided by our 19,600. There it is. Oh, that's 19,000. Oh, there we go. There. Excellent. Enter. Gives you an ugly fraction. Let's see if we can math frac that so it's a little prettier. Okay, math frac. Yeah, okay, minus 27 or over 2450. Minus 27 over 2450. Oh my goodness, that's not very pretty either. But there's your A value. Okay, so here we go. Write the formula now. Y equals to minus 27 over 2450, right? X minus 140, there's your vertex, squared plus 216. That's the formula for the archway. That's how it works. Ugly question, ugly numbers, but now you got the formula. Now, check out what else it asks you here. It says, what is the height of the archway at the point which is 50 centimeters from its outer edge? What does that mean? What are they talking about here? What they're talking about here is this. At a point out here, which is at 50 centimeters, they want to know, how tall is this archway? Why would they want to know something like that? Because if you think about it, symmetrically, that tells you that you have that big of an opening to get things through. And if, let's say this is an archway into a museum, that means you can only get an artifact that is that tall through that archway. See what I mean? So that kind of point is very, very important. So they want you to find out at that point of 50 centimeters from the edge. Well, if you think about that, 50 centimeters from the edge, that's an X value of 50. So what you're going to do is you have to substitute into this formula the value of 50 in order to figure out that height. Well, wait a second, that sounds really complicated, doesn't it? Well, actually, nah, it's not that problem at all. Watch, you have y equals to minus 27 over 2450. That's the only part that's a little bit difficult. 50 now minus 140 squared plus 216. Now, that sounds like a calculator problem. Let's go and do this. And I'm going to show you two different ways of doing this right away. Okay, so check this out. Clear this stuff out of here. So 50 minus 140. So I'm going to do that first because BEDMAS tells me to do what's in the brackets first, right? I get minus 90. I'm going to square this. So I'm going to go out and I'm going to go minus 90. Oops, and I have to put it in brackets. Otherwise, that minus isn't going to count very well. Minus 90. I'm going to square it. Okay, enter. I'm going to multiply this now by this guy out here, right here, the minus 27 over 2450. So times bracket minus 27 over divided by 2450. Okay, bracket, all right, enter. And now I'm going to do the last step of adding 216 to it. Add 216. So it's a bit of a calculator issue, but it tells you your height is at 126.7 centimeters. 126.7 centimeters. Look at that. Confirm it just by looking at the calculator again. Yeah, 126.7. Wow, isn't that interesting? Now, is there an easier way of doing this? Well, actually there is, and it's all based on your calculator. So I'm going to show you something incredibly cool. I'm going to leave the 126.73 up there just so that you can see it. But I'm going to take this and I'm going to go back to my y equals 2, and I'm going to actually plot that equation right there in red, all right, into my calculator. So here we go. Bracket minus 27 divided by 2450. There's your A value, bracket. Now I'm going to need another bracket here, and it's x minus 140, bracket squared. Look how complicated this looks, right? We're almost done. Plus 216. Now, there's the formula just as we determined it. And if I graph this, watch what happens. You don't see much. And why is it that you don't see much? Well, the reason why is because look at this wonderful thing back here. Look at this. This is an archway, and let me clean this up so that you can see it a little bit better. This archway, if you remember, oops, I don't know why that came up. This archway, if you remember, right, is 280 centimeters by 216 high. And we're dealing with a window setting here of, right, 10, 10 up, 10 to the right, 10 to the left, 10, 10, zoom standard. So we have to change this window setting to be at least 280 and at least 216 this way. So let's go back into the calculator. Let's change the window settings. We go to the window, which is here. Leave the minus 10 there, that's fine, but X max should be at least 280. I'm going to make it up to 300. Okay, I'm not too worried about the scale value. That's another war we'll deal with later. Minus 10 is fine, but the Y max now has to be at least 216. I'm going to make that 220. Now, everything else looks fine. Watch what happens to the graph now. Guess what? There's your arch. Isn't that interesting? That's what it's going to look like on the calculator. Very, very nice. And as a matter of fact, you can figure out one extra thing here. Remember, we wanted to find out where was this point, and the point's got to be up here somewhere, right? We want to find that point up here that was 50 centimeters away from this edge, right? So how do we do that? Well, that's actually kind of easy to do. It's very, very simple to do just by knowing a couple things. Go into second here, and this part right there, which says calc. Now, in second calculate, look what you have. You got a value. And watch what happens when I hit that. It asks you, what's your X value that you're looking for? Well, I'm looking for an X value at 50. That's what I'm looking for. Well, hit enter and watch what happens. Does that number look familiar? 126.7? Yep, that's exactly the same way. So you can actually calculate this algebraically like we did down here, or you can use your calculator like we did here and find the exact same answer. Depends on, you know what? Depends on the person. Some people might look at this calculation and go, oh my goodness, manipulating the graph is much too difficult. I would rather go out and just calculate it. But look at the advantages of using the calculator. It even tells you right here by this little blinking star. Now I'll get rid of this. There's the blinking star. It tells you exactly where you are. You're on this part of the edge, and you're exactly 126.7 centimeters high. I think that's really valuable to know how to do this.